So first off, big f of x is what we get when we do the antiderivative of little f of x. It's just some notation. So, and we're on page 495. All right. So, when you take the antiderivative of f of x, we get big f of x. And we evaluate that, it says from a to a. Because that right there is a to a. So that would be f of a minus f of a, which is 0. So shortcut of that is, if you're trying to find the area under a curve and it starts and stops in the same place, there is no area under the curve, which makes sense. And you just have some picture. Let's see if I can find a picture somewhere. Yeah, like right here, and you're finding the area under that line. There's no area right here because there's no width. So that's why. If these two numbers are the same here, then it has to be 0. And you don't have to go through all that, but there's the why. Okay, part 2. If you're going from A to B, and you know that C is some number in between A and B, then we can separate that out. We can go from A to C. Do you have these notes? You do, don't you? Yeah. Okay. A to C plus C to B of those two. So like if I was going from 1 to 3, I could split that up into going from 1 to 2 and then from 2 to 3. Okay, so number 3, the only difference here is the endpoints are flip-flopped. So that means instead of finding the antiderivative or the area under the curve this way, we go from left to right, we'll go from right to left. So that's just going to change direction, which just changes the sign. So if the answer here was K, then here it would be negative K. So if for some reason you have to flip-flop the endpoints, you just change the sign. That's all it does. It's the same thing here. If you end up going from higher to the lower, so it's saying if B is the smaller number, that's what B is less than A, that's what that would be, then that just means it's the opposite. It would be the negative. Again, we're just flipping the signs. Those two really are very similar, if not the same. It just depends on how you think about it. Number 5, if K is a constant, then that means we can bring that K out in front. And we actually did that yesterday. That way you just don't have to multiply it over and over and over again. That just simplifies the arithmetic for us. On number 6, also, we have already done this, we just haven't formalized it. If you're taking the antiderivative of two things added or subtracted, you can separate that out. It's kind of like you're distributing the antiderivative. You can find the antiderivative of the first, plus or minus the antiderivative of the second one. Both dx. Which we already do that. because we do them separate anyways. Okay, so on 7, an even function means that splits it in half. You have the same thing on the left-hand side as you do on the right-hand side of the y-axis. So if that happens, if I'm going from negative a to positive a, then the area over here is going to be the same as the area over here, if it's an even function. So what that means, it would be the same, this would be the same as 2 times the integral from 0 to a of f of x dx, which just means I could take double of this side and get the same thing. It's just sometimes that's necessary, especially if you're given information in the table, because they may not give you all the way from negative a. If it's an odd function, that means it's symmetric about the origin, which means whatever is, let me put it over here, whatever is here would be flipped across the x and across the y on the other side. So that's symmetric with respect to the origin, things that look like this. So if I'm going from negative a to positive a, then the area under those curves actually will cancel each other out. They're exactly the same, except for one's positive and one's negative. So that really simplifies the integral. It makes it 0. Okay, so this happens a lot, where on the next page, up at the top, they give us some information up at the top. They don't tell us what f of x is, but they tell us that the integral from 0 to 3 is 6, and then when I go from 3 to 7, it's negative 8. So we can use that information to figure out these answers. For example, on this one, this first one, it goes from 3 to 0. It's very similar to this top one, but the endpoints have flipped around. So how do I show that? Yes. Now I'm going to write it out the long way just so we don't lose it, but that's exactly right. So from 3 to 0 of f of x is the same as the negative from 0 to 3 of f of x, which, like you said, would be negative 6. Negative 6 would be a fine answer there. I'm just being more particular. All right. We'll go, yeah, I don't want to lose any of these, so we'll go straight across. From 0 to 7, so that starts with, oops, didn't do that. Starts with this one, and ends up with this one. So from 0 to 7, how would I do that? Yeah, that's right. It is the same thing as from 0 to 3, f of x dx, plus the integral from 3 to 7 of f of x dx. So that's 6 plus negative 8. And that's because 3 is in between 0 and 7. So that's why we can do that. What if it starts and stops at the same number?
0.
That is 0, yes. And it would be the antiderivative at 3 minus the antiderivative at 3, which 0 is a fine answer. There's no, really, you don't have to show that work. I'm just not wanting to lose anybody there. On this next one, I can pull that 3 out in front. And then I'm going from the higher one to the lower one. And up here it goes from 3 to 7. So what do I have to do if I flip it?
The opposite.
Yep, change it to its negative. So I'm going to put a negative in front of that 3. And I can replace this with negative 8 because that's what it was equal to. So the next one, we're going from 3 to 7, we're adding and subtracting, then I can pull it out, and I can do that to both.